So, good afternoon, everyone, and we are here for the follow up session, which is going to be taken by Saurabh. Welcome, Saurabh, and thanks for offering to take us through. mm, I think today we are going to go to an online Jupyter notebook, read from a file, write to a file, plot some data, plot some theory data, plot some observed data, and do some curve fitting today, tomorrow. That is our plan.
Yeah, thank you so much, ma'am,
Huh?
for having me.
Mm, mm,
So,
mm.
today we'll be doing some basic stuff, which is reading the data files and writing them and then loading them up. So, it's basically more about file handling and how you basically cope up with astronomical data sets.
You can start your screen share. I'll add it into the studio and then hand over to you. Saurabh has been for a long term associated with us at the planetarium. He was there when we first had the code camp few years ago, and he has been very enthusiastically using this his coding skills in many contexts. And he has done some work recently. I think he's uploaded to GitHub as well, right? Okay, so that's
Yeah,
you, Saurabh, your screen share. So if you go to
yeah,
your, what I will do is, so you have come to your Jupyter notebook. I think let's
yeah.
pause for a while and just make, just alert everyone. Everybody, please open your online Jupyter notebooks or whatever environments you want to work in, and so that you work along with him. And we are going to give some pauses, Saurabh, just so that people catch up with us and so on.
Mhm. Yeah,
Okay,
sure, ma'am.
so I'll
Yeah.
hand over to you.
Okay. So I'll just give you everyone a second to at least uh, go through the just open the Jupyter notebook, and maybe you can just try to open the online version if anyone hasn't already uh, opened that. So just go to jupyter.org, right? And then there's an option which says try it in your browser. And okay, so yeah. Now I guess now you have to go to try classic notebook. So what you'll see is that there'll be an online Jupyter notebook which will be open in your screen soon. So you just have to wait a couple seconds more, and then it will be open automatically. Okay. Okay. So this is what exactly a Jupyter Notebooks looks like. So for the past few week, I think you all must have gone through some of the basic stuff related to Jupyter and Python in general. So Jupyter Notebook is nothing but more towards an interface, let's say an environment which gives you to work in Python. Let's say you stay in a home, right? And you can work in any other room. So the work that you do can be same in any other room, and that other room defines that your environment, right? So this Jupyter notebook gives you an environment. So it's not only based on Python. You can even work on a different language, which is like Julia. So Julia is another programming language which you can work on Jupyter notebook. Then there is R, and then there's another data analysis uh, softwares or languages which you can work on, right? So this is just a basic interface about Jupyter notebook. So what you have to do is so this tells how you can open a Jupyter notebook in your um, laptops. Now, most importantly, is that sometimes you might feel that how you want to run these commands, right? So these commands are actually based on Linux based system. These are actually Linux based systems in which you run these commands. So most of you people must be having Windows based system. So that's why we're working online. Now, for those who want some permanent solution, that they do not want to use internet for a while and then just do the whole thing, so they can just simply download another software which is called Anaconda, and it actually is available for sorry. Okay. So it's actually available on every platform, be it Linux, be it Mac, or be it Windows. So just have to download Anaconda, and I'll just after this I'll start. So you can just go to individual edition, and then you simply click on download, choose your systems, and then you're ready to go for full Python interface. Okay, so I guess, ma'am, we are ready to start with the whole thing. I hope I am audible to everyone, right? Because I cannot
Uh,
see.
I was muted. Yeah, yeah, yeah. So we are fine, and let us stick to online Jupyter notebook for all the exercises we are doing.
Yes, yes,
Hmm?
yes, definitely.
And because the installing, etc., for newcomers is going to be a bit of an issue.
Yeah,
So
exactly.
everyone
That's
come to online Jupyter notebook,
Mhm, mhm.
and I think that gives rise to the problem that some of the things which are there in the background in Anaconda or Canopy are not here. So that
Yeah,
is
yeah.
where help will be needed as to what are the
Mhm.
libraries to import
So
as we
what
go
I
along.
understand, what I understand from the FOSSI lectures is when you actually try to open the in-thought canopy using a terminal or any other thing, so it actually pre-imports the library. So it imports library itself, the NumPy or maybe SciPy or maybe Matplotlib, and that's why you have to put some extra sort of initials in front of the whole function so that you are able to call that whole library, right? So I'll just start up with this whole interface. This is the whole Jupyter notebook. There are different menus here, and there are some other options through which you can work upon. Now, one other important aspect about this interface is that this Jupyter notebook acts as a calculator, right? So if I just enter any number in here, let's say 567 plus 234, and I click on run, it just runs it and it gives me the output, right? So this is my in cell and this is my output here, right? So I'll just toggle line numbers. Okay. So another important thing, that if you want to run this particular cell, you don't just have to every time go to the mouse and click on run. You just click shift plus enter. So let's say if I write print hello world, so you have to do nothing, just click on shift plus enter, and then your whole program will run. So I assume that you all have been through some of the very basic stuffs of Python. So I'll just jump on directly to the libraries and stuff and trying to define different types of functions and how to basically generate some data sets, right? So in astronomy, when you're actually trying to understand some particular astronomical phenomena, what happens is that you just get some data sets, right? But how do you actually try to understand, or how do you try to make sense of the data set? They're actually based on modeling, right? How you model a particular thing. Let's say I'm having
Uh,
some data set from.
Saurabh, will it be
Mhm.
okay when there are some questions if I come in and just pass on the questions to
Yeah,
you?
sure, sure.
Because you
Just
won't be
stop
able to see the questions
and
when you
then
are full screen there.
yeah.
Prajwal says, can we use Jupyter Notebook app which comes with Anaconda installer?
Yes, 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 exactly. So when you install Anaconda, what you'll see is that there are different types of environments, which gives you Jupyter Lab, Jupyter Notebook, Spider, and different stuff. So you can just click on Jupyter Notebook, and it will open up some sort of web browser thing like this. This is my web browser, Safari here. You can simply use this as a web browser, and this is how it will open, right? And what you have to do is nothing. You just have to open a Jupyter Notebook by clicking on New, and just click on Python 3, right? And this is how this particular thing will open. I hope I'm clear.
Yeah, yeah. So please go ahead with what you were
Okay.
doing on the notebook.
Okay, great. So as I was talking about that, how do you make sense of astronomical data sets? Is basically the modeling, right? If I have some data sets of, let's say, black holes, right, and I'm having some extra data sets or some radio observations. Now, how do I understand what exactly type of source that is? So I try to model them. So modeling means I have my own theory and I'm trying to test my theory with my observations, right? So that requires how I interpret the data sets, how I interpret the observation that I have received from those telescopes or some satellites or any other sort of instrumentation which we are using to have those data sets, right? So for the first time, for the first thing, there's certain libraries, Python libraries, which will be importing in, which are essential, which are very essential for astronomical purposes and in general for scientific purposes. So one of the most important library is NumPy. So how do you import a library in Python? Is quite simple. So if you have gone through the whole Python thing, so you must have noticed something, that Python is actually a very, very high level language. And also its most important thing is whenever you're trying to run some syntax, right, the whole thing, it actually is more towards the English semantics, right? So let's say if I want to import some library, let's say I want to import NumPy. So I'll just simply write import NumPy as NP. Now, if you try to make this sense in the English language, what you will understand is that I'm importing this thing as NP. So I'm renaming this whole library while importing as NP. So this is actually one of the conventional methods that you can use. I can even name this as Saurabh. I don't have any. I mean, this will work. This is nothing but just a convention that we normally use. So you can simply use NumPy as NP, and this will actually import the whole library. So it is actually working on internet, so that's why it will take a bit more time to import this library. But if you try to work it on your local machine as in your laptop, or something which you are having offline, this will go on very smoothly. So for now, I'll try to work on sorry, I'll try to work on my local machine so as to get things in a faster mode, right? So first I'll import NumPy as NP. Now, another library which is very important is basically for plotting, which we have is matplotlib. So matplotlib.pyplot. So in matplotlib, there is a certain module which is named as pyplot. Now, if you try to understand how a library is actually structured, so let's say this is my whole structure. Okay, this is my whole structure, and this is the whole library. Now, there's certain sections which are called modules, right? So different modules are called by putting a period in front of the library, like this matplotlib period as in the dot matplotlib dot pyplot. So I'm calling this whole module, right? So I'm calling this whole module as plt. Okay, so this is another library which we use for plotting purposes. Another important library is AstroPy, which we'll be using in further exercises. So I'll just, for the sake of generality, I'll just import it. Import AstroPy as let's say anything. You can give it in let's say 80. Okay. So I've successfully run the code. So if you see here, white means that it's actually idle. If it's actually black, this means it is, this whole code is running, right? And even you will see a star which is here, right? As soon as the star disappears, this means it is actually working. Now import, the libraries are imported successfully. How will you understand that it's the code has run successfully? Importing libraries doesn't give you any output. Okay, it's just that saves in your memory, and that's it. So I assume that most of you people are eighth class above, if I'm right.
Yeah, that's what we told when we wrote to schools, and of course, many of them are college and from the
Okay.
various WhatsApp groups, people who have joined in,
Mhm.
and there are some seniors also. So,
Okay.
but to schools, when we have written, we have asked eighth and above.
Okay. So because what we'll be doing is we'll be doing certain mathematical functions which I think might not be in their syllabus. So okay. So no issues with that. Okay, I'll just get started. So first thing is basically trying to generate numbers, right? So I am actually so students actually ask me a lot is that how do you generate data? So data is nothing but a set of numbers, right? It is just set of numbers, some decimal points, some integer numbers, right? So in Python here, how do we actually define those numbers? It's based on if they're integers or if they are not integers. Basically, if there are let's say some decimal points or some float values, right? So let's say 3. So 3 is an integer value. So 3 is basically regarded as int. I'm not writing the code, I'm just trying to explain, right? This is not a code. Now, if I write 3.0, 3.0 is a decimal number. So how I regard it as, I'll regard it as a float number. This is a float value, right? Right. Now, there are certain types of data types which are basically bool. Bool is nothing but true or false, right? True or false is nothing. It's just a bool value which tells you that whether this whole thing is um, behaving true or false, right? So this is how the different type of data sets, different type of data types are there. So let's say I'll generate some value for x. Now there is a function in NumPy which is called linspace, np.linspace. I'll call, so if I want to call a function from this whole library, I first have to put my initials, which I called my library as np, and then I have to do it np.linspace. Now let's say I don't name it as np, I name it as import numpy. Okay. Now what I'll do is I have to write this whole thing, and what I'll do is I have to just simply call it numpy.linspace. Right? This is how you import library. Now let's say I don't want to put anything. Okay, I don't want to put this whole thing. So I just want to import this whole function, just this function from the library. So the simple code which I'll write is import num from. So I'll just write from numpy import linspace, right? This is how I'll import this whole function. So have to do nothing. I just have to do this linspace, right? Now, so what happens sometimes is that you are not able to understand that what are the different arguments that this function takes. Arguments as in the different types of values or the different types of data what I want to give this function, how it actually works. So what you will do is nothing but you just type the function name, linspace, put a question mark in front of it, and do shift plus enter. So what you'll see is here, you'll see a help menu which pops up, and you'll see the first argument that it takes is start, then stop, number, and so on, different values it takes. Now these are the parameters. What these parameters mean? So you see, start, the data type it takes is an array like, right? I mean, an array of values or simple value. The starting value of the sequence. So I want to generate, let's say, number from 1 to 10, right? So what I'll do is I'll generate. So I'll just do it simply, and from import numpy is np. I'll just delete this. So np dot linspace, and then parentheses as in brackets. So the start value, let's say my start value is let's say 1, and I want to generate values from 1 to 100, right? 1 to 100. Now I want to generate 1 to 100, and I want to define it with let's say number of values, how many number of values I want between 1 to 100. Let's say I want 1,000 values between 1 to 100. So the third argument will be num, which is the number of samples to generate. Okay, let's say number of samples to generate, which will be 1,000. I hope I'm clear in this aspect, right? So x, so what this linspace is doing is basically trying to generate 1,000 values between 1 to 100, and each value, the interval between each value, each two values is actually same. So linspace means actually is actually linear space, which means uh, equal intervals between values, right? But I am defining it here as total number of 1,000 values. So it defines certain interval between 2 points, and that's how it generates values. So let's say x is equal to linspace np.linspace 100,000. I'll run it, and then what I'll get is x. I'll just do x, and this is the type of values that I'm getting, right? So you see here, it has generated how many? From 1 to 100, it has generated how many values? So let's say if you don't know that how many values this particular whole thing contains. So what I'll do is I'll do len bracket x. So len is an inbuilt function of Python. Len means you can say it as length. Okay, what is the length of x? So it will give me 1,000 as I have generated the number of values, right? So this is x is equal to 1,000 values. So this is an array of values, right? Now, okay, so this is how I generated my values. Now, what I want to create is I want to create a sinusoidal plot. So let's say y is equals to, I have to create a sinusoidal plot, np.sine. Now there's a function in numpy itself which is sine, and I'll just do x. What does this mean if you do it in mathematical terms? Let's say I want to generate 1,000, I want to plot a sine plot, right? So for every x, I'll have a particular sine value, right? So those sine values are actually defined at different points in the x-axis. So this is my x-axis values, and this is my y-axis values defined by sine. So if you have done simple mathematics, basic mathematics in your 10th grade or 10th above, you'll understand that this function, what does this do, right? So I'll do this, y is equal to np.sin x. Now what I've done is I've generated some data set. This is called a basic simulation. If you can, this is a very basic version of a simulation which you can think of, or let's say generating simulated data sets, right? So I'll now plot my values. How I'll do is that I'll call this my plot library, which is plt. I'll do plt.plot brackets, and I'll just do x comma y. So the first argument that this plot takes is the x-axis values, and then the second argument that it takes is basically y-axis values. So I'll do plt.plot, and this is how I'll get. So a very simple version to look at it is basically generated how many values from 1 to 100, it generated values, and this is how it's giving me the plot, right? So this is the x-axis values is 1 to 100, The y values is basically my whole function which generates this. So let's say I want to generate from 0 to 2 pi, which is a much conventional thing to do. Okay, I think I must charge my laptop. Okay, so I'll just do it to star np dot pi, and this is how I'll generate. I'll do simple same thing, and voila. So this is how I'll generate a simple sinusoidal plot, right? This is a very basic version. Let's say okay, let's say I have another function which is, let's say, cos x. So I'll do x1. So I'll define my function. This is x1. I'll define another function which is a x2 np dot, or let's say let it be x itself. Okay, because x axis values will be same. This will be different. So y1 will be sin x, and then y2 will be cos x. Okay, and let's plot two different functions. So first I've plotted, this is my sin x and this is my cos x. Okay, now this is my plot. Now another important aspect is how do you differentiate that what, which graph or which plot is of what function. So this is how we do the labeling. Okay, this is how we put a sort of a legend, which I suppose you have already done. So a very simple way of doing this is nothing, just to just go on that function which is the plotting. So you see this y1, right? So I know that y1 is basically sin x. I'll do another argument which says label. Just do nothing. Label equals to, put inverted commas, quotes, just do sin x. Okay, and do the same thing with the cos plot. Do nothing but label equals to cos x. Okay, so now define the label of what exactly this plot means. Now I have to put in a legend. Legend is nothing but a simple sort of let's say marker which gives that what color plot is, or what plot of that particular color, or what color of that particular plot means. So I'll do plt dot legend and just parentheses and nothing else. Okay, and there's another function which is called plt dot show, which sometimes is important for showing the plots itself in the whole thing, because sometimes what happens that you might not see this particular plot, so you must have this thing as output but not the whole plot thing. So you just have to put plt dot show if that happens. So you just do this and see, we have got the legend here. Right now there are certain different arguments, and you can just change the where exactly I want to put this thing. I want to put center, on the top left, on the top right, bottom, or anything else. You can even decorate this whole plot and make it more like a publication quality plots. In science, when we are trying to do some new research and we want to publish some paper on that particular experimental data or on observational data sets, so what we do is we have to have these plots of a very good quality, publication quality plots. So you can add some grid as well. Let's say plt.grid. So what it does is it will create a grid and the background like this. Okay, so it will create a grid something like this, right? I can decorate it more. I can make it a much more. I can make it much more better. So what I'll do is I'll try to disappear these background grid values. I'll try to blur it. Okay, I'll simply try to blur it. Or let's say I'll try to decrease the opacity of that particular grid thing. So what I'll do is there's another argument in grid which stands for alpha. Okay, so alpha stands from 0 to 1. So alpha value ranges from 0 to 1. So that depends. So 0 means that it will be visible, and 1, oh sorry, 0 means that its visibility will be 0, and 1 means it will be fully visible. So if I do 0.5, so you see in the background the grid is actually much less it's much transparent, right? So this is how you can decorate your whole plots. Let's say I want to change the location of this thing. Okay, I'll do loc, and you can just put it top right. Okay, okay, so it's upper right basically, sorry. Okay, so here we have gotten this thing. Now you can even change the size of this whole thing. Okay, you can change the size of this whole plot. How you'll do that? You can add another command which says plt.figure. This is another function of this matplotlib. So every plotting thing we do with this, most of the thing we do using plt. This is any this is pyplot module of matplotlib. Okay, there are many certain functions of matplotlib not in the pyplot uh, module, and that this is for different parameters. Let's say I want to change the font of this thing, I want to change the font size, and different parameters, right? I can do that stuff as well. So I can change the size of plt.figure. How? So in plt.figure there is another argument which says fig size, which stands for figure size, equals to an another parentheses. So in parentheses I have to give the width and the height. Okay, so let's say I want to make it longer. I'll do it 7 comma 8. Let's say 7 comma 9. So what you'll see is you'll see a figure which size has already changed like this. So 7 is my width. It's actually squeezed a bit, and you can see the height is actually increased. Right? This is how you can change the size. This is for rectangular values. Let's say I want to stretch it a bit more. So I'll do 10 and I'll do 7. So sorry, my code is taking a bit time due to its memory. Okay, so now you can see that I have done this whole thing, right? Okay, so I hope I'm able to get my point out there to all the people, right? So at this point, I would just like to take a halt and see if there are any questions. Ma'am, are there any
Uh,
questions? That,
Yeah, yeah. I just check what questions are there. Ritvik, there have been several video. I mean, couple of videos before. Just look through all of them. This is a code along kind of a project, so that's what you
Mhm.
have to do. All right. Now that is Ritvik's question, and I don't see any other. The prerequisites here. If you have done some kind of coding beforehand, it will help you. But the current project is essentially whatever you have done in other environments. Come and do it in Python. So that is the project. Saurabh, I was just wondering at this stage or some
Mhm.
later time, suppose we want to draw a plot like this and plot another one underneath it, not in a separate
Okay.
window. So,
I
will
mean,
you do it now or will it interfere
same.
if we do it now?
No, no, it's
Like
okay.
for
I can do it.
instance, I mean, I was just thinking like when we do pulsar plots, we do one plot where we have intensity at the top, and then we do a small plot below where we show the position angle kind of a thing. So one
So
large
you
rectangle
mean,
above and one small.
you mean the
So
subplots
those
thing,
kinds
right?
of things, different plots in the same window.
Okay, okay, I
Will
get
you
it.
or will you do it some other later on? That's fine. I mean,
Yeah,
if
I can
it's
do it
not in
right
the
now.
flow just
Actually,
now, you do it later on.
no, I can do it right now. I mean, that would be a better addition to the whole plotting thing, right? That would be a better thing. Okay, so what ma'am is trying to say is basically trying to plot different plots, but not in the same thing. Okay, and like this, you see the cos and sin. It's actually plotted in the same thing, right? So that's I don't want to plot it in the same thing. So what I'll do is I'll try to create a subplot. So subplot module is another module in the matplotlib.ply plot. What it does is basically it tries to plot in different plots, but in a different small windows, multiple plots. So there are actually different methods by which you can create a subplot. One of the most used, which I personally use for subplots, is this particular thing. So there's a function called plt.subplots. Okay, now plt.subplots, what we have to do is we have to define the axis and the, oh sorry, I have to define the figure and the axis of that plot. Okay, I've defined. So this PLT of subplots have two. It actually returned two things. One is the figure, and another is the axis, right? So let's say I want to draw two plots. Okay, for cos and sine. So what I'll do is I'll do PLT dot subplot. So if you want to see that what different things this function can do, you just have to copy this subplots. Just do a question mark, and then you'll see. So you'll see that how what are the different arguments that it takes. So first one is the how many number of rows you want, then is the number of columns, right? This is how you can see it here. Okay, and you see that what I do is it returns two things. One is fig, and another is the axis. Okay, now I have chosen a figure and ax as my default name. You can name it as figure, you can name it axis. It's totally up to you. Okay, I've chosen just for the sake of conventional, saving the convention. And okay, so let's say I want to plot two plots, like one in the left side, one in the right side. Okay, now you see there are two plots. So it has two columns and one row. So n rows will be one, n calls will be two, right? So I'll just delete this one. Okay. Okay. So I've defined two plots. So what you'll see is here there'll be two plots, and I've deleted everything. So there'll be nothing which will be plotted already. So there'll be nothing plotted. So you see there'll be two different plots. Okay. Of this particular size. I'll just remove this size thing. Okay, these are two different plots. Now I'll plot. So what I'll do is I'll plot sine plot in this one and cos in this particular thing, right? So what you have to do is you have to use this ax instead of plt. So now this whole thing is now let's say absorbed in this particular ax thing. So now you have to do ax and what axis you want to use. So right now I have just used two columns, right? So the first will be 0. So in Python, always remember the counting starts from 0. So 0 is the first value, 1 is the second value. Okay, so 0 means the first plot, dot plot, and you do x comma y1, right? I hope I'm able to uh, uh, get you all thing is clear, right? And you have to do x1 dot plot. It's the same thing for a sine thing or cos thing by 2, and you plot it. Let's see what happens. Okay, so now
There
what
is
I
a
have done is I
question.
have plotted successfully, right?
Saurabh,
These
there
are,
is one
yes, ma'am.
question, though it's not very clear to me. I don't know if it's clear to you. The REJ is asking, can we also give links to the various commands for each of the libraries? It's not clear to me what.
Link as in
Let me
let
fly. You
me,
can't see the studio, right? So you won't be able to see the
uh,
question. You are in your full screen mode. The question is, can we also give links to the
I can
various
try to see.
commands for each of the libraries?
Okay,
Maybe
let me.
RJ, maybe you clarify your question. At least I am not able to understand. Let me flash it again, Saurabh. Yeah, that is the question.
We also give links to the various commands.
Uh, I don't know whether it's my network or Saurabh's network. Looks like mine. So, all right. Uh, Yeah, RAJ, I get it that yes, there are a lot of commands, etc., which are coming up. Well, you will have all of these always to access that particular video. But yes, there is one reference document which I'll circulate tomorrow, which has a kind of a reference. It gives many of the commands as a reference document. So that I'll circulate tomorrow. I have it at the planetarium. I'm not there today. I will circulate that tomorrow. I think Saurabh has maybe lost network, so he will come back, I'm sure, soon. Mm, okay. So yeah, I take your point, RAJ. Yes, and I also feel it. Though I have done a lot of programming Fortran, but Python. I am also learning along with you people. Yes, and you may feel that it is a little overwhelming, but then all of this, everything Saurabh has done is always visible to you on YouTube. And but the point about a reference document is taken, and we'll circulate that tomorrow. A reference document with most of the commands. Saurabh, actually, the comment was just saying that many of the commands that you are using, is there a kind of a reference document which can be referred to? I remember that
Oh,
Fossey gave us one PDF, so
mm-hmm,
I'll
mm-hmm.
circulate
Yeah.
that tomorrow. And if
Okay.
you have any other reference documents, you could share those also. So
Mm,
now you add your screen share again.
yeah. So sorry, actually my laptop just died.
Yeah,
So
yeah. I know, I know. We in online we have to be prepared for all of this. That's okay. That's
mm,
why I mean, since I'm there, I stepped in for a while to just have a chat, and
okay.
so this is fine. You are there now, so you'll not be able to see the studio, but I'll keep tabs on the studio. So you
Yeah.
go ahead.
Okay, sure. Thank you, ma'am. So, okay. So I guess what you are trying to say, that how will you understand, or how will you learn that what particular thing has that particular set of function, right? I guess this is what you're trying to ask. If I'm not wrong,
Yeah, I think so.
right?
I
Because there
think
are so many different
yeah.
functions, there are so many different type of libraries. So how will you remember each of those, and to call how to
Can I
call them?
add one point here, Saurabh? I think to, I mean, just telling that the thing is that the only way you will get to have a feel of, like comfort with them is by
Mhm.
going on and on coding and
Exactly,
using this.
exactly. So you
That
just have to
and a
practice.
reference document will help you. We will see.
Yeah, definitely. So okay, so we are plotting two different types of subplots. So this is how you will get those subplots. Okay, and you can just try to decorate it as per as what you like. You can just do different types of line widths. You can change the color of the plots. You can change the size of the plots. You can even add some sort of texture to the plots. Different type of backgrounds. So there are a lot of lots of things that you can do, and some of the examples that you can see is. If you see some research papers, you can see some of the plots which are constructed in Python. They are so amazing, and they look so great that it's actually amazing. So you can do a lot of things. It's just that you need to understand the whole thing, and you need to practice as much as you can. This is nothing. This is exactly like maths. You can only understand maths only if you practice it and practice it. There's no other way. So same thing goes with coding. You just have to practice it, and you have to do as much. You have to spend as much time as possible. Right. So this is how you can do two line plots. Okay. So another thing you can add is changing the line width. How you want to see the width of this particular plot. So there is another argument in this plot which says LW, which stands for itself, which is it says line width. So let's say I want to put the line width as 3. Okay. For the first plot. For the second one, I will say let line width equals to 5. Let's say I want to also change the color of this first plot. So you have to do nothing, just color argument is C equals to an inverted quotes. Okay. So let's say the first plot I want to do black. So the code for black, or let's say the reference for black color is K. Okay. And let's say I want to do another one. Let's say I want to do some color. Let's say line. Okay. You do this. Okay, sorry. And this is how you get the plots. You just have to figure out a way how to do these plots, and how to uh, generate some amazing stuff using this whole thing. Right. I can show you some examples of amazing plots that I did for my some work that I was doing. Let's say okay, some of the work I was doing, and you can see some of the plots. Maybe not this one. Okay, like these, you can try to plot different type of images stacked together with the color barcodes itself. This is two-dimensional plotting of a black hole, that you can say that's an image of a black hole, right? So this is how you generate data sets from your own theories, doing your own models, and then doing that whole stuff, and then just stacking them together. The subplots thing, the same thing that we did in here is just these simple things. So you have to just have those plots, and you can do some amazing plots like this. You can add some titles in these plots itself. You can plot this line, add something into this whole thing, do the color bars like this, and do some amazing stuff that you can do, right? So there are different arguments that you just have to keep exploring this stuff. And another aspect of doing coding is internet. If you have there are some issues, go to the documentation, this whole library, which is mat.lib.org, and you will see some of the amazing stuff, how what you can do using this library. Just go to the user guide, and there are some tutorials that you can do. There are some advanced tutorials. There's some like this. You can create histograms, you can create columnar visualizations, which I did. Then choosing different colors and specifying colors and all of the different things. So this is how you can do. So if you know what is actually is latex. So latex is how you basically do the, when you see in your textbooks, you have your textbooks, and you see that there is some subscript written upstairs. You can see some Greek letters. You can see some different types of renditions, mathematical equations, the integrations and all other stuff. This is all coded in latex. Okay, so you can even do the latex in here. How? Let's say I want to make the title of this plot. Okay, let's want to make the title. So I'll just go x.0 dot title. I guess it will be set underscore title, the command for this thing. Okay, the first plot, and I can let's say I want to do sin x1. Okay, what I'll do is I'll write sin x under dollar sign. So this is just for those, if just for the fun, if you know latex itself, just do r. Okay, and you just go underscore one. So just for those who know this stuff. So you see that one just goes down in the below. So just for those people who knows latex and who want to put up some latex things, let's say underscore one, or let's say they want to put some let's say alpha. I can just make it alpha. There's the alpha. You can increase the font size of this whole thing. So the different things that you have to do, and it all comes by time. Okay, I won't be doing everything in here, just those stuff, so that you guys can get started and started doing that whole stuff. Right. So are there any questions still here? Anything? Then we'll move on to the next step. Anything till here?
No, I don't see
See.
anything. We can actually now move to reading data from files, maybe.
Okay. Okay, sure. So, okay. So for the first thing, what I'll do is I'll try to save some data sets, right? So how do we save data sets? That's another thing. So there's command in NumPy which says as np dot save txt. Okay, this is another command for NumPy, which saves the text that you want to do. Let's say I want to save my sign values. Okay, you see this is my sign values. This here y1. So let's say I want to save my sign values. So what I'll do is I'll do y1. Okay, and I'll name the file name as. So if you see the help menu of this thing, so the first thing is file name. Sorry, I was doing the opposite. First thing is the file name, and the second thing is the data that you want to save. Delimiter means how much space you want to give between different columns. The header file, if there is anything, comments or anything and stuff like that. Okay. And this is FMT. FMT stands for nothing but some the formats, whatever format you want to save on. Let's say you want to save into dates format, or if you want to save in some let's say complex format or something like that, you can use this thing. Okay, there are different types of formats in which you can save. So for now I'm saving in just into txt file. Okay, this is a text file. If you guys know what a text file is, it consists of ASCII characters, which means you have ASCII characters, which means you have numbers, you have alphabets and all that stuff. So I'll save my data set, let's say with the name of, so f name is basically let's say I want to save my tutorial one, or so tutorial.txt. Okay, and I'll say my data set, let's say this is my y1. So I'll do y1, and okay, this is what it's saying. np dot save text, I'll do this one. Okay, now my data set is my whole thing has been saved. How do you know that where it's saved? So you have to see that where exactly your file was created. Okay, So if I just hover back to where my whole file was created, if I'm not wrong, it will be somewhere here. Okay, this is my file which I'm running. So in the same directory, it will be stored. So you see, this is my directory. It has been stored as tutorial.txt. So how do I import my data set in my this thing? So this command, let's say my data set is data. There's command called numpy.loadtxt. Load txt. So load txt is another command which what does is it basically imports my data that has already been there in the directory. Okay, and I can import it like this. So an inverted comma. So every string thing that you do, every character that you want to define, let's say directory or the name of thing, or I want to set up title, everything will be in quotes. Okay, so I'll just do, let's say, okay, so the file name was tutorial. So you can even do tab thing, sometimes what happens, you want to complete it automatically, right? So you can do just do a tab thing and it will complete automatically, right? Or let's say if there are multiple finds with the same thing, let's say t, there are multiple things in the same thing, it will do like this. So you have to choose it and then do shift press enter, and that's how you loaded data in the data sets. Okay, this is my data. So if I plot my data, which is plt.plot, just do a simple data, which means the exact this is which means my y-axis values, and I get my sine values, right? See, I hope everyone is doing this thing and I'm not going too fast. If I'm going too fast, just stop me in between and let me know where exactly am I going fast. Because this is actually a very important aspect of how to save things and how to read them into Python. Because initially what happens that when you're trying to understand some data sets and you want to do some research, or let's say you want to work something on data analysis, something like stuff like that, you have to first be able to import this data stuff, right? And there are different types of data stuffs that I can think of, which means some radio observations, some X-ray observations, right? Some fMS data, or let's say some planetary data or some exoplanets data. So how do you read that? So some data sets are in txt file like this. Some of them are in binary, zeros and ones. So in binary, and those binary have to be read by Python. So there's different type of context, and I think it will be out of the scope for this particular basic stuff, because binary reading binary data is a bit more complicated, because let's say if you all of you people are just the starting are the ones who just are starting the Python, so it will be a bit difficult to cope up with the binary stuff. So we'll just go on with the ASCII data for now. So if everyone is able to do that, I'll be moving forward. You can just simply type maybe yes, and then I'll see here if it's going smoothly. Maybe. Uh, okay, I'm getting something like this that I'm neither visible nor audible.
No, you. That's fine.
Okay.
Actually, I was just hiding your screen share because it is doing that infinite thing.
Oh,
Yeah,
okay, okay.
fine.
So I was
Yeah.
just seeing the comments. So I just wanted to see that whether people are understanding this stuff or not. Otherwise, I'm just speaking, and maybe people are not getting it. So it might
So
not
if
be
any
good.
of you feel that it's going a little fast or so, you just mention. If I mean, the way it is going is fine, the speed is fine. Yeah, Prajwal says it's fine.
Okay.
So I have not yet heard anybody saying that you need to slow down. So go ahead.
Okay. Okay, great. So I hope everyone has done till here. Okay, so this is how I'll my load my data in the whole thing, right? So I've saved my data sets, and this is how I'll plot it. Now let's say I want to save my data sets in multiple columns. Okay, now let's say I have this thing. Okay, so I have two data sets. Okay, let's say I have two sets of data sets, and I want to save them. So how I will do that? There are different types of methods in which you can do that. A very simple one is to create a two-column list. Let's say my data sets. I'll define my whole. Okay, so I'll just create another thing. So I want to save this whole data sets into two things. Okay, so what I'll do is I'll create another. Let's say the um, I'll just create new. Okay, new. I'll create a bracket, which is the big bracket, square brackets. And I'll do y1, comma y2. Okay, this is my data sets defined. What I'll do is here I'll save it. Okay, so what I'll do is here I'll just put it here, np.save txt. I'll save it using the same name, and it will override my previous file which already was there. I'll do like this, put new. Okay, so now our whole thing is saved, right? Now I'll call my whole thing again. I'll load my whole data set again. This is it has been loaded, right? So if I want to see that whether my what exactly is my data thing, I'll do this data, and you'll see something like this. Okay, you'll see that there are two different types of columns. So one column is here and one is here. So and even you can write that what exactly is the shape of this thing. So for people who have done matrices, matrix thing or something like that, you'll understand what exactly is the let's say how many number of rows are there, how many number of columns are there, right? The data, what type of matrix it is. So you have to do is like this data dot shape, and you will see. So you see that there total number of two things, two columns and 1,000 uh, row. Oh, sorry, there are two rows and there yeah, right. These there are 1,000 columns and two rows, right? Two different types of data sets. So how will I call them? Nothing. My first, let's say my first thing will be data. And if you have gone through the fossil electives, you might have gone through the slicing thing, right? Slicing mean you want to slice the data sets into different sections. So here I have two different types of data sets, right? In one column and another row. So I'll do 0. This is my first thing. And let's say my x, this is my x1. Okay, and let's say my another thing is data 2, data 1. This is my second column, right? I'll do like this. You can see if the data has been imported, data has been sliced correctly. How? You can see the length of the data. So length of x1, you will see 1,000 values, right? And same goes for the second thing. You can see 1,000 values. Okay, so data has been imported correctly. Now I can move forward. What I'll do is I'll do plot dot data. No, I'll do plt dot plot x1, which is my first data set, which stands for sine. Okay, I'll just do it like this. Sine, how will I know? This is my y1 and this is my sine. Okay, this is x1, this is x2. Sorry, this is my x1. Okay, I'll label it as, let's say, sine x. Okay, my other thing is x2. Okay, I'll label it as, let's say, cos x. Okay, I'll put up a legend. Okay, always remember that label will come here. Or if you don't want to put up a label, you want to put up like on how you're plotting this thing in the serial wise, you can even put it a list in here or whatever the values you're having. Okay, like this, like sin x, or you can put up a comma, you can write it cos x, like this. Okay, you can do like this, but I am just choosing that way. Okay, do plt.legend and just do a plt.show, which is just nothing, which just shows me the plot. Okay, somewhere I did this thing. Okay, okay. So another very important thing which I want to mention here is basically the error that you get in your Python. Now, instead of learning how to remove, how to just code this thing, you have to understand what type of errors there are in Python. So every time you code, you will see some error, right? If there is some sort of bug in your whole thing, so you want to understand that what type of error did I do. So if you see here, the error that I'm getting is an attribute error. Okay, attribute error stands for that what type of thing I misspelled in here or what type of function I did which is not present in my library. So you see that module matplotlib.pyplot has no attribute plplot. So there is no such thing in this whole pyplot. So this meant somehow somewhere I spelled wrong, and I have corrected that. Right? I did this, and voila, I have got my plot thing. Right? So this is one way how you can do this whole thing, data sets, right? I hope I'm clear here, which is saving the data sets, was first simulating some data set, second is saving the data set, and third is loading the data sets and then plotting them. So these are the things that I've done, that we have done till now. And if there are any questions, I'd like to see them. If there are any questions, you can post them in the comments itself.
I'm just checking. I'll check and tell you about the questions.
Okay.
Uh, Uh, okay. Sargam, no, the Astro Adda is a different group. The Telegram group is for the just for the Python coding is different, and that's it. I mean, everyone seems to be
Okay.
following you. I hope all of you are doing some of the stuff at least along. Some of the stuff may be going on a little too fast for you to do it completely, but the basic thing for the data reading and doing the plotting, etc., please code along. Chalo. Screen blurred, Advai was saying, but maybe that was network issue. Maybe it is sorted now.
No.
Go ahead
Mhm.
now.
Okay.
I'll add your screen share. Yeah.
Yeah.
Okay, go.
Okay, so this is the stuff that you can try to do, and okay, so this is my first thing. Now, there's another important thing that you can do is this all stands for one-dimensional plotting. Right? This is my one-dimensional plot. You can do a two-dimensional plot itself. Two-dimensional, as in, let's say this is my sinusoidal, and this is how you're looking at it in front of it. Okay, this is how my plot is going. You can look at from different perspective, which gives me a 2D thing. Okay, how it's changing in this and how it's changing in this thing, right? This is a two-dimensional plotting. So it's more like an image that you can see it here. Okay, let's say I want to create a two-dimensional sinusoidal thing. So another thing that you can do is like this. Let's say for sine plot I want to do two-dimensional plotting. How will I do? Okay, so first I have to create two-dimensional array. Okay, a two-dimensional array. Two-dimensional as in it has columns and it has rows. So if you see my x1, it just have one thing, which is rows. Okay, it has nothing. It just have one column of the whole data. Okay, so if you just do x1 dot shape, you'll get 1,000 rows. Okay, this is just 1,000 data sets. Now I want to create a two-dimensional thing. Two-dimensional as in 1,000 cross something. Okay, 1,000 cross some 1,000 cross 1,000 matrix. So how will I do that? Let's say my new data set. There's another function in NumPy which does this thing. Is called np.meshgrid. Okay, meshgrid. What does it? What it does is it tries to map the one-dimensional thing into two-dimensional thing. Okay, let's say my new x comma new x is equals to np dot mesh grid. So np dot mesh grid gives me two-dimensional array data set, two-dimensional array data sets, and that's why I've used two different x. Let's say this is my new x1, this is my x2. Okay, and I want to create my x1 as in two-dimensional thing. Okay, so what I can do is x1 comma x1. Okay, so now you see that new x1 the shape hai, you will get it's 1,000 cross 1,000. Okay, now how will I plot this thing? You actually cannot plot it using plt.plot. I mean, you can plot it, but you won't get anything useful. Okay, let's say I use it using this thing. You won't get anything useful. Okay, it's just this thing, whole absurd thing, and like this. But you won't understand anything. What you'll do is you'll do plt.timeshow. Okay, do this thing, put this value new x1 and s2. This is how sinusoidal plot actually looks like when you see it from a two-dimensional domain. So to better understand this, let's say okay, so let's say this is my whole paper. Okay, this is my paper. Now this is how my sine value is going on. Okay, this is my how sine value is going on like this. Now this is my perspective of view. Okay, now what I'm doing is I'm actually changing my perspective. I'm not viewing it from this particular, so you can see that how it's actually changing in just one direction, right? I want to see that how is it changing in this direction itself. So I am now changing my perspective like this and seeing how it's changing in this direction as well. So this is how I'm getting it. Okay, from two sides. So you see that this thing, as I go up, I have a peak in this plot, and as I go down, I have a depth, which is called a valley. Okay, so this is my up, this is down, this is up, this is down. So whenever you see an up, you'll see a sort of bright thing. Okay, a bright thing. Now, as I am going down, you see how it's going down in a valley, and as I'm seeing a dark thing. Okay, let's say I change this thing. I'll just copy this whole thing. Okay, now here. So what I'm doing is I'm creating my whole thing. Let's say I'm not going from 0 to 2 pi. I'm creating 0 to 10 pi. Okay, I'm creating from 0 to 10 pi. So I'll just, so you see that here now I'll just put it y1 because this x1 is basically the imported data set which I've saved. I don't want that. I'll do this like this. Okay, this is my new x1 shape. I don't require it now. Now I'll do this like this. This is how you look a sine wave from upper side. Okay, and if you look it from in the front, so this is so if you see this particular thing, this is how I'm looking from this upside. Okay, this is upside. Now if I see how I'm looking from this side, this is how it is looking. So you see this is up and it's going down, and this is how it's going now. Let's say I plot. Okay, it would be better option if I do this thing. What do it then? Oh, I want. We won't see it. Okay, yeah, you won't see it. Okay, no issues. So this is how my whole thing will look like. Okay, this is a two-dimensional plot of sine wave. So I am show what I am show does is actually showing an image. I am means image, show means showing. So it's actually showing an image. So every image that you import in Python will be a two-dimensional image. Every time you see an image, it's actually two-dimensional image, which means a two-dimensional array. Okay. So this new x1, how you know that this thing is a two-dimensional? You just do np init new x1 dot shape, and it tells me what exactly is the shape of this whole thing, which is 1000 cross 1000. Now if I do this whole thing for the cos, okay, I'm doing it for the cos. So you see, okay, now so if you have done some basic mathematics, you will know that where there is the top of that sine wave, there is the valley of the cos wave. Okay, so there where there is bright spots, I'll see the dark fringes, yani dark spots. Where there are where there are dark spots, I'll see the bright thing like this. Okay, to show you a difference, what I'll do is I'll create, okay, okay, now I'll create y2 alag se. Okay, copy this thing, let it be new x, just let it be new x. Okay, no issues with that thing. This is be new x 1. Now first one is y1, another one is y. Okay, now I've done this way, I've done this way. Now plt.im show the new x1, and this is just thing. Okay, so this doesn't work. Just do like this, and you do like this. Okay, so it actually changed because I have just saved it as the same thing. What I'll do is I'll just change the names again. 1 2 3 4 4 4. Okay, so it'll be new x1, this will be new x3. Okay, so you see where there is dark fringe, you'll see there is no dark fringe, right? Where there is valley, there is dark type of fringes here. It's actually phased out a little bit, but you can see the point in here. Okay, I hope everyone is understanding this thing, right? I'm just doing a two-dimensional plotting of sine x. You
All
can even
right.
do for
Yeah,
yeah.
there are no questions as of now. So
Okay.
go ahead, and perhaps now in a simple that the curves things, the reading. Actually, I missed it a little bit. Reading part, maybe just we do that today before we conclude, so that we can take it up tomorrow for the curve
uh,
fitting.
which reading
Reading
part has
of the files. You have already done that, is it? I'm sorry. For a
yeah,
while, I
I
was
think
not there. I
you
was
just
not
have to,
there.
it's actually dependent on what type of data I want to study. So I'll give another example. I guess that would be much more
One
clear.
or two examples, and if possible today, or if not tomorrow,
Mhm.
reading dates also. Because when we are
Reading
doing
data.
ephemeris
Yeah,
data, we
that
are
will be
reading
that can
dates.
be done maybe tomorrow, I think,
हाँ
and
हाँ
that would
ठीक
be.
है, we can do that tomorrow. आज simple ones we will do.
अभी let's say
And
I have another data set. I'll just
hmm.
see it एक बार कहाँ है. Mm, okay. So I have here.
There is one question. Rahul Zota is asking why the phase comes in. That is the acha. You're Rahul. You're talking about the two plots, two different plots, is it?
So
Again, I missed
it's
exactly where
basically,
that phase difference was coming in. Are you plotting different things, sine, cos, or adding a phase
oh,
difference?
it's basically for cos and sine. So cos and sine are
Cos
actually,
and sine.
cos
They
is
have that
actually
phase
multiplied
difference.
by pi by 2. So yeah,
They have that. It's intrinsic to the maths of it.
yes.
All right, I see your screen share come in. Fine.
Okay,
So please go ahead.
okay. So let's say I have, so what I'll do is I'll try to give an example of another library which is very important in reading tables, and one of the very, very strong libraries is Pandas. Okay, so Pandas is another library which is used to read data sets, okay, from different types of data sets. So I'll import this library as import Pandas. Okay, so I just did import pandas. Now, what data set I'm using right now, I guess you might not have that, so it's totally okay. You can just simply see it and just see how it's done. So this data set is actually one of the data sets used in 2009 to understand Sagittarius A star, supermassive black hole. Okay, this is from the radio observations, which tells us how the intensity is changing as per the length of the distance between two or more telescopes, which is called the baseline length. It's totally okay if you do not understand the physics behind the whole
Mm-hmm.
thing, but
Yeah.
what now?
You go ahead and show this, and probably tomorrow we will give data to the participants in a simpler context.
Yeah,
From
sure.
Fossey, I
So I
have
just give
data
the
to do with
coding
a
thing.
simple pendulum. And
Yeah, yeah,
tomorrow we can take that up. Today, you go ahead and show this.
yeah. So okay, this will be the whole thing. So first I have to input the where exactly this my data set is. Okay, so maybe I have to put my whole um thing maybe. Okay, no. Okay, now it's working. Let's see. Okay, it's not even here. It's somewhere else. Okay. So what I've done is here is okay, this code is a little bit longer. Okay. So what I've done is here I have imported some data set from Sagittarius A star black hole, supermassive black hole of radio observations done way back in 2009, and it's basically set of visibility amplitudes if I want to understand it, and visibility amplitudes versus the baseline length, which means the distance between two telescopes. Okay. So so data sets, this is I'm actually reading it through a function called read underscore table from pandas itself. Okay, and this is the header. I have put it as none because there is no header in my file. So I'll just do it. I actually have already done the whole coding. Then I'll just explain it to you how I have done it. Okay, so if you must have studied this whole thing, I'll just do it in, let's say, sections. Is just an example of whole thing. So what I've done is I want to read my data sets. Okay, and this is actually my binary data. Okay, this is an example of a data set which is in binary. Okay, now most of the data dat files that you will see, it will be in binary, but somewhat they will be mentioned that whether it's in text file or binary, you have to see it for yourself. So reading data for data sets, I have what I've done is basically I have simply imported as pandas, and I want to see what type of data set it is. I'll just put it data. This is how I'll get my whole data thing. Okay, so what you see is here, this is my whole data set which says, which has some date, which is, this is my name of the source, I suppose. Okay, this is the name of source, this is my whole date, this is my time, this is my baseline, which is my antenna what I'm using, this is what type of band I'm using, and this is the UV, and then so on so on. Okay, different whole stuff. Okay, this is my whole stuff. Now in my this radio observations, what I have is called the UV plane. Okay, if I want to understand this particular image, so this is my U, this is my V. Okay, this is my UV plane, and I created some empty list because I wanted those data sets to be plotted. There's another important thing, which is the intensity, which I called it as amplitude, visibility amplitude, and I created an empty list of amplitudes and my error in my observation, which I called as sigma. Okay, now I have read my data sets and I want to understand that where exactly is my whole thing. So let's say this is my whole data set. Okay, as okay, I'll just print it here itself so that it's easy to see.
Sort of actually, yeah, you could show it and run the whole code, but I'm just thinking that such complex thing right away before we
No,
have a
I'm just
simple
thinking like
one may
what
be a
type of
little
data
difficult for
that
everyone, but yeah, it'll be good to show the power of it. So you
yeah,
go ahead and show what the code can do. And though, I mean, I'm just telling the participants don't get overwhelmed by all the
yeah,
new
yeah,
things which would have had come in. And we will do a simple one immediately following this. But it is good, as I was saying right in the beginning, it's good to know the what the monster can do. Although
yeah,
today, I mean, in our current camp, we are only cracking a peanut with the bulldozer, but it is good to know the power of the bulldozer. So, from that point of view, go ahead. And we will do the simple context tomorrow, right? We will send the data
yeah.
file also and do the simple context
We'll
tomorrow.
do the pendulum thing if
Ha,
that's
ha, ha. Yeah, yeah, yeah. So, but you do show what this code can do because then that will give an
okay.
idea as to what all can be done.
Yes, yes. So what I was saying that is there are different columns and telling me what different type of data things are present here. You see, this is the name of first is the name of the source, then is my what type of date, what day I took my data set 2009, which is the year 097 is my date from 1st January. You know the number of date. So 97 will be somewhat in April. This is my time UTC. This is my name of the antenna is J. LO, low bandwidth. This is my UV and stuff and stuff. So what I did is here I just simply ran this code. Okay, I simply created an empty list. I knew at what place my data is there. I basically what I did is I sliced my whole data from different sections, and only those sections which I wanted. I did this. What I want to plot is uh, the square root of u and v square, and I'll just do a simple plot, which is nothing but u equals amp, and this is my whole data set plotted. You can so this is my visibility amplitude versus my baseline length. So what I'll show you is the power of Python is like how you can plot the error bars again. So I'll add up something called marker. Marker is nothing that what type of marker you want to see. So now for now it's a dot. Let's say I want it plus. Okay, plus is a much better thing. Let's say what's the size of the marker. Let's say 5. Okay, what's the color of the marker? Let's say okay, let it be this thing. Okay, what does it say? Marker size. Okay, so marker size is nothing but I guess it's size. It's not even size. Okay, it's basically S maybe. Okay,
Actually,
this
I've
is
been
S.
noticing that the size has been giving some errors, even in other
Size is
contexts. Even
basically
line width size has been giving some errors sometimes. Maybe
yeah,
something
yeah.
is
I mean,
changing.
it's okay. I mean, sometimes what happens that we forgot what type of arguments is there. You simply go to this. What I said is the help menu, which is very important. Go to this help menu, and it will let you understand. S is the marker size. Okay, so I can just put it like 45, and I'll get some beautiful thing. Let's say I'll just don't know 45. This is how I get plot. Let's say color. I want some black. Okay, I put my black thing. Okay, now let's say I want some I want the labels. So you know the label thing, how you plot it in X. So in X, it is basically my UV uh, distance. This is my whole thing. Okay. In my Y, as I told you, it is nothing but visibility amplitude. Okay. Now let's say I want to put grid. I can put my grid. Let's say alpha equal to 0.7. How can I make it more interesting? Okay, let me change the size of the figure. Figure size, it's always better to put it on the top of the whole thing. Figure, let's say I want to put the fig size equals to 10, let's say 6 comma 10. That's better. Okay, now what else can you think you can do with this thing? So I plotted this thing. Okay, this seems a bit more larger. I can put it like this. 8 comma 9. No, 7 comma 10. So fixed size is basically which tells you what is the width in parentheses 7 comma 10. So this is my 7, this is comma 10. So you see this my label is actually very small. I can change the font size of my label. How? Go to this font size equals to let's make 20. You can do this whole thing for the Y label as well. You can go comma font size equal to 20. You see size increased. Okay. Let me increase the size of my scatter plots. Size of my marker. Let's say I want to make it 65. Okay, that's a bit more bigger. You can even change the this text. These are called text. Okay, these are called text values. You can even change the font size of these text values. And I won't go into details because there's lots of stuff that still needs to be done.
Hmm.
So
Hmm.
here, okay, so this is my whole thing, plotting. I can do another very amazing thing is instead of doing just this thing, I can plot the error bars. You have some uncertainty in between your data that how much error you have in your while in your observation. You can even plot that is nothing but is another function called error bar. Okay, so you do the same thing, uv, comma am. Now there is another function in here called y error, which is the error in my y-axis. Now I said my error is basically sigma, which I put it up in here. I can put it my sigma. Oh, where is it? Okay, this is my sigma. Okay, and okay, let's do this. See, something like this. So it's actually plotting a line plot. Now I don't want a line plot. What I'll do is here I'll do this fmt equals to okay, maybe it will work. Yeah, it worked like this. So you see, this is my error bar, how it's actually changing this thing, right? I can put up this, let's say this is my FMT. What else can I do with my plot? You just have to go to this thing, error bar, do a question mark, and you can see this FM color. This is E line width. I can change my line width as well. Let's say 5. I can what else can I do? Okay, limits. There's something stuff. Okay, e color. I can change my color of my error bar. Let's say my color bar. Let's say red. So let's just put red. Red is basically R. FMT is basically what type of I want. This is a point thing I want, and this is how the color of it will be. This is how I got my color of red bar. Line width. Let's make it a bit more small. Okay, much better. I can choose instead of dot, I can put up, let's say I put up D. D is for diamond. So you see in here, you get D as in diamond, right? This is how you can plot different type of stuff using, um, Python. So this is a very
Yeah.
basic example
Hmm.
on how you can basically create some data sets and create data sets, save it, upload it, and then use for your own scientific purpose or analysis.
Thanks, Saurabh. That's nice. Actually, since I missed a couple of times, because it will be nice to leave a little bit of homework.
Mhm.
We did reading of data from a file, and we
Yes,
did writing of data to a file.
yes,
Both we have done.
yes. So we have
Uh,
just done the very basic aspect of saving and
Huh, that will
uploading.
be enough for the homework. I was just thinking, why not
Mhm.
everyone maybe do this thing? Like you make your own theoretical curve of some y is equal to mx plus c,
Yeah.
and then take out the data of that as a I mean, as
Mhm.
theoretical data, get
Mhm.
out some numbers or do that theoretical curve y
Mhm.
is equal to mx plus c, give some values for m and c,
I can give
get
another
some
example.
numbers,
Mhm.
get some numbers out of it. but
Mhm.
then slightly make them different from the exact values, as if there would
Yeah.
be some experimental values. So then you plot the line of y is equal to mx plus c, and you plot your points as scatter points. After you write down your points using y is equal to mx plus c, फिर उसको थोड़ा सा फर्स्ट कर दो points.
Yeah.
So
Yeah.
plot a line as well as the observed data as homework for today. Would that be a good thing, Saurabh?
Yeah, that would be nice. And I
And
guess what
any
would be
other
a
homework you
really,
want to suggest?
yeah, so there can be other exercises for people who are doing their undergrads and above, or even for 12th class people. You must have studied the Boltzmann function, right? Or Boltzmann, yeah, the Boltzmann distribution. So what you can do is you can create a function. So to create a function, you have to do nothing. Just do def, which is define. Then just name the function that you want to do. Let's say Boltzmann. What are the parameters that it will take? Let's say it'll just take x semicolon, and then do the whole thing, whatever you want to return, and then just do return. And let's say I want to make a straight line. Okay, let's say I want to make a straight line. So I'll do straight, and if ever you see anything which is in green, light green like this means that is an inbuilt function of Python, and you cannot use it to name anything. Okay, so let's say my straight it is dependent on x, y is equal to m star x plus c. Let's say even it's dependent on c. Okay, I just want to supply my value, so just do return y. Okay, now I did return y. So if I supply x as, let's say, np.len space 0 to 5, okay, let's say 100 values. And if I did this, let's say data is equals to, I call this function, okay, stra, and this is my x. I even put my x as x, and c is basically this intercept. Let's say c equals to 10. Okay, okay, it's not defined. So I have to put it m as well. I forgot, sorry. Now you have to put the slope value. Let's say slope is -5. Okay, got an unexpected. Okay, I haven't run this thing. So now I've got the data set, data straight, plt.plot, do this data, and you got a straight line. Right? So in similar way, you can make a Boltzmann distribution, you can make a Gaussian distribution, you can make any type of distribution plot that you want according to your own purposes. You can plot the Planck's law if you are interested. Do that stuff, plot this whole thing, make a very beautiful plot, try different stuff, and I guess that would be a very good exercise to do at home.
Yes, as a theoretical curve. And
Yeah.
in addition to this, take out the data from this. So maybe take it out as
Mhm.
an array, and
Mhm.
then in that array, you fudge the data a little so that it may
Yeah.
look like observed data or something
So
like
what you
that.
can do
So
is
you
have
plot
a,
both the line as well as the data points. That's what the
yeah,
homework I was suggesting.
yeah,
So,
sure.
yeah, sorry, Saurabh, I interrupted you.
No, it's okay. So to fudge the data, as in what ma'am said, is basically to add some errors in this whole thing. So how you can do is a very simple thing. You can, let's say, okay. So let's say you can use a function which is called random. Okay, so maybe
Uh,
that would be
Are
too
there
much. You
was
can do
I
it
was
next.
not thinking of doing that. I was saying maybe a data file of 10 or 20 data points, no more.
Hmm.
And for a few
Okay.
points, just add some error by hand. This is because
Okay.
this is just the beginning exercise. Of course,
Yeah,
tomorrow
sure.
I think we are also going to give you actual data file of simple
Hmm.
pendulum lab exercise. So that will
Hmm.
have its own errors and so on. So that can, I was just thinking we should do this because we want to do curve fitting tomorrow.
Yeah, yeah,
Right,
sure,
Sora?
sure. Yeah.
And you were saying that other contexts like, other Gaussians and Boltzmann, those
Mhm.
also, I mean, can be done. But it may be good to just start with the simplest first
Yes,
for
yes,
today's
definitely. Mhm.
exercise.
Yes, ma'am.
Right?
That would be
Hmm?
fine.
Ha
Mhm.
ha. Amritanshu says that Samantha challenge plot. Yeah, that was my
We
intention,
can do
that
that.
you should
Mhm.
do your Samantha challenge plot.
Yeah.
So for that, what you need to do for Samantha challenge plot, you need to take the theoretical data. Right now, it is not coming from an equation, but your theoretical data is coming from ephemeris, and draw that as a line, and your observe points on the line. And tomorrow we are going to discuss how to do curve fitting and so on. So that is one context. Other context is draw a line from a equation, add some observed data by adding a little bit of error in the observed data points. So all of this,
Mhm.
and then suit yourself. And as Saurabh says, go more than this. I am trying to say no, no, simple, simple, simple today. So I was
Yeah.
saying no, 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 let's do more, more.
I mean,
So
it's
you,
again, it
can
depends on
all
how
suit.
they.
Everybody can suit what you
Yeah.
want to do, as simple as you want to do, or as complex as you want to do. So maybe do we call it a day today, Saurabh, or was there any other thing
So,
that you wanted to discuss?
maybe I think that would be it for today because there we have done a lot of things and it would be nice for them to practice them
Yes, yes. Everything you
tomorrow.
just done, please make sure you have done it before we do tomorrow. Otherwise,
Exactly.
if in these kind of things, if we get left behind even a little bit, we keep
Mhm.
getting left behind.
Yeah, exactly. So I mean, it actually Python is very very strong, programming language. All my work that I do is in Python, and you can do all your research in Python. You can do all your analysis, all data analysis. And today it's actually booming out like nothing. So Python is very important. It would be like very great if you could just somehow master this language, and then maybe it would be very good for your career choices if you are planning to do your whole research work or anything in Python
Mhm.
in physics
Any
or
field, probably one will find applications for it. So,
yeah.
okay. So, what was I wanting to say? Yes, in the Telegram group as well as the WhatsApp group, which is
Mhm,
there right now,
mhm.
I will circulate the data files needed for the curve fitting, etc., etc. Whatever we can find, and if Saurabh, you have some other context, you can
Yeah,
share.
I have some.
And there is one PDF sent by Fossey, which
Mhm,
is kind of a guideline for each of the commands. Somebody was asking, that also will be
mhm.
shared. And one Fossey video has been uploaded to the drive. So take a look at that too. As time
That,
goes on, I will try and upload more videos to the drive. So
yeah,
that's it.
okay.
We call it a day, unless there are any
Sure.
questions right
So
now.
maybe there's another exercise which can be done. Maybe, ma'am, if you remember
Go
that
ahead.
in the
Go ahead.
Vigyan Samagam, I uploaded some Stokes file of pulsar. So maybe they can plot them. I mean, it would be nice just to do the plotting.
Yeah, yeah, yeah. So you can share
So,
the files again in the group
yeah.
if you
Or maybe what
tell
can
them
be
what.
done is
But of course, otherwise you can actually go to European Pulsar Network
yeah,
database. That gives
yeah.
you a lot of Pulsar
Or maybe
average
I can
profile
share the
data.
link of that GitHub link, right? Maybe they can use that. So I'll share this GitHub link. What you have to do is you just have to download this whole stuff and do nothing. Okay. So there's okay. So what you'll see is there some data sets which is present in this particular thing, which is pulses, which is nothing but some pulsar data of different Stokes parameters. No need to go into much detail. You can open this thing Stokes underscore yes, and you can try to explore the whole thing. Okay. For those who want to understand much more, they can open the other file as well. You can see how I've read the data files, we have sliced it and plotted it like this. And this is how it should look like somewhat for some pulsar, right? That would be nice exercise if you guys do this as well. But it's not just doing shift plus enter and just running the code. It's more about understanding what's actually happening in the code. What exactly
Yeah,
do this mean? I'm writing colon
yeah.
comma two.
For that
That's
reason,
actually
yeah, copying a code will not be very helpful. So we will have to, any of these codes, even the other code which was shared earlier, try to build it up bit by bit and then look up
yeah,
the code and try to get help from the existing code. That is the
exactly.
way. All right. So we end it now.
So,
Thanks,
yeah.
Saurabh, so much. So tomorrow, 3
It's
p.m.
boring.
Okay with everyone? Tomorrow, 3 p.m.? Tomorrow, 3 p.m. is all right. We may as well take the decision here. Saurabh,
Uh, it's fine
it's
by
okay
me.
with you? You're
Yeah.
sure? 3 p.m. tomorrow? And
Mm-hmm.
nobody is saying that there's any problem with it, whoever is there. So let's keep it tomorrow, 3 p.m. All right?
Mm-hmm. Sure, ma'am.
Okay, so
It
I'm
would be
ending the
fine.
broadcast. Thanks everyone for being there. Thanks, Saurabh.
Thank you. Thank you so much, ma'am, for having me.